Hello and welcome to this session in which I will discuss in more depth database connections with latest release of PowerServer and also with REST API projects. Let me pop up for a couple of seconds this Open Elevate conference disclaimer. And we are ready to start with the session agenda. I will begin introducing the concept of connection pooling and how it works. Then we see how it affects PowerServer projects. What is the key difference between long-running and short-lived database connections? Common pitfalls, or let's say bad surprises from this pooling when used in PowerServer project. A new breakthrough option for retaining same database connection for the entire session. And the problem of excessive server calls that is typical in legacy client-server apps, which obviously were not designed with 3-tier and HTTP and latency in mind. In this concept, I will brush up on the concept of call merging. Next, we analyze REST API projects and how to have them dynamically connecting database per given client request. Here we have an API, not a cloud app, so it may be a little bit trickier. I'm a PB and PowerServer enthusiast, an Appian MVP. I have been leading lots of migration projects to all PowerServer web and mobile products, and now enjoying this new family of PowerServer targeting installable cloud apps. I'm working more and more with web frameworks to design plugin-free user interface as cross-platform alternative to Power Builder and PowerServer Cloud frontends. My topic is Vue.js and Quasar to call a REST API built with Snap Develop, and I gave a long step-by-step session about this in previous Elevate conferences. So, connection pooling. It is a known fact that database connections are expensive to create. So connection pools come into play when you have a large number of requests that generally take a short amount of time. You reuse a prior database connection in a new context to avoid the cost of setting up a new database connection for each request. So each physical database connection is cached in the pool when idle and used by any client when necessary. What happens when connection pool is full? If the maximum pool size has been reached and no usable connection is available, the request is queued. And the pooler then tries to reclaim any connections until the timeout is reached. And if the pooler cannot satisfy the request before the connection times out, an exception is thrown. So why connection pooling? Connection pooling is a well-known data access pattern. Its main purpose is to reduce the overhead in performing database connections and read-write database operations. Let's say that at the most basic level, a connection pool is a database connection cache implementation. So why connection pooling? Of course, this question may sound rhetorical if we analyze the sequence of steps involved in a typical database connection. The reason should be clear. So first of all, opening a connection to the database using the database driver. Opening a TCP socket for reading and writing data. Reading and writing data over the socket. Closing the connection and closing the socket. It becomes evident that database connections are very expensive operation and as such should reduce to a minimum. Here is where connection pooling implementations come into play. By just simply implementing a database connection container, a pooler, which allows to reuse a number of existing connections, we can effectively save the cost of performing a huge number of expensive database trips. This boosts the overall performance of our database-driven application. The Power Builder traditional client-server application uses the transaction object to connect with the database server. So the transaction object stores and passes the database connection information. It is a direct connection made from the client to the database. It's called client-to-server connection, in fact. The upper part of this picture shows how transaction objects in Power Builder contains parameters to connect the database and performs retrieve update. And below is instead shown the PowerServer scenario. The installable cloud app provides a more secure way in which the database connection is made from the PowerServer to the database, so server-to-server connection. The database connection information is stored in a cache in PowerServer, and the transaction object is only used to find the connection cache. It no longer passes the connection information from the client to the server, and therefore, for installable cloud app to work, you will need to configure a cache and then map the transaction object to the cache. Here, SQLCA is mapped to cache name localSA, and localSA entry in the PowerServer configuration file has all the information to connect the database with the proper driver and settings. So this is called static database connection because the connection configuration, including connection cache settings and transaction to cache mappings, is created before the app is running in the database page of the project painter, and it gets deployed to the PowerServer C# solution. On the contrary, PowerServer dynamic database connection means that mapping is created when the app is running. A dynamic mapping can be created in the application script using the database parm cache name and cache group parameters. Such dynamic mapping with the database parameter has priority over the static mapping if both exist, and this picture shows a possible scenario. The clients start the PowerServer installable cloud app, passing cache group as an argument in the query string. This is intercepted in PowerScript via the common param argument of the application's open event. And then the database parm, the DB parm property of the transaction object is built in such a way that it contains the cache group and the cache name, so that the SQL transaction object can dynamically map the right database among all the caches, which connects to the database with different privilege and use multiple groups, for example, to identify different environments. The settings are stored on the PowerServer side in the server API appconfig application JSON. Let's see now the difference between long-running and short-lived database connection, which may impact not only performance, but also runtime behavior. So client-server application in traditional Power Builder projects use long-running database connections. A client connects with the database when the connect statement is executed, and the database connection is kept open and used by that client until the disconnect statement is executed. This means for a particular client, the database connection is always the same one. In installable cloud app web application instead, like in a PowerServer project, the database connection is short-lived because the database connection is made from PowerServer, not from the client. It is made by PowerServer Server API. And the database connection is cached in the pool when it is idle, and it is used by any client when necessary. This means for a particular client, the database connection may not be always the same one. It may use any database connection cached in the pool. For example, first connection A and then connection B, etc. And for a particular database connection in the pool, it may be used by different clients. For example, first by client X and then by client Y, etc. This different behavior may lead to pitfalls when it comes to PowerServer and in general cloud apps. In traditional client-server application, for example, temporary tables will not be destroyed until the disconnect statement is executed. So after this temporary table is created, you can perform operations with this temp table at any moment you like. Same if you use context variables. You create them after the connect and they are removed at disconnect. But in installable cloud app, you cannot get expected result because the temp table is only valid in the current database connection, which is a short-lived connection. So if the temp table is created in connection A and operations in connection B try to access this temp table, then you get an error such as table not found, or the temp table created in connection A is destroyed when the connection A is returned to the pool. And then operations with this temp table will fail even though connection A is selected again from the pool. And same is for context variables. When connection is released to the pool, they are lost. To eliminate this difference, from PowerServer 2022, you can set the long connection database parameter so that the installable cloud app can support the long-running connection and persistently use the same database connection for a particular client. If you set this option to 1, an installable cloud app gets the same long-running connection as the Power Builder native client server app. And for instance, a temp table will stay active all the time and the same temp table will be used during the all user sessions. Besides that, it's highly recommended to increase the transaction timeout value, which is 2 minutes by default, to have the same interval as the session timeout value, an hour by default. This is to prevent transaction timeout during the session. Because if the transaction times out, then a new database connection will be created, which means the temp table is not the same one. Keep in mind this can introduce server overhead because connections are stateful, they are not released, and the more clients you get at the same time, the more connections are open. A best practice is therefore to have 2 transaction objects in Power Builder. For example, SQL-CA that uses the pool and SQL-CB that uses the long connection parm and enables long-running connections just where you need. Let's now focus on tuning excessive server calls. What are them? They are, for example, embedded SQL, select, insert, delete, update, cursor, or invoking storage procedure or database functions, data windows functions like retrieve, update, share data, or events like SQL preview, retrieve row. And they all may lead to network chatter and low response of your original Power Builder scripts. So how to fix it? With separation of concerns. Namely, replace cursor with SQL in data window if possible and eliminate recursive embedded SQL. Eliminating data window of computed fields calling in turn user functions with embedded SQL. Partition transactions of embedded SQL and data window using database storage procedure, an old way to move business logic to database, but still efficient. You may also want to move business logic to server-side REST API by means of rewriting the logics in C# and deploy it as REST API that you can call from your PowerServer backend. But this, of course, requires some learning that goes beyond the automatic mechanisms of PowerServer. Or, of course, from PowerServer 2022, you can group multiple requests using the new PowerServer label objects, which does nothing in client-server projects, but merges independent server calls when used in PowerServer. Independent requests means the execution of one request does not rely on the execution result of another one in the same merge request, or one request does not use the return value of another request in the same merge request. Let's see a few examples of merging server calls. So script on the left encloses between the start merge and the stop merge function, the end merge function, a number of server calls like data store one retrieve, data window one retrieve, an embedded SQL select, and so that is rather than as many round trips as these four requests, as many round trips client to middle tier to database with potentially high latency in local area, in wide area network or cloud infrastructures. There is only one request that goes to the server side, as well as one HTTP reply back to the client. Server script instead on the right shows the stop mode parameter in the start merge function. This is 0 by default, but if you specify 1 like in this example, your request will return if any error occurs in the merge request, with possibility of testing individual result set and in particular SQL code to figure out which one failed and maybe roll back all transaction. So the merge label should only be used to merge independent requests. Independent requests means that execution of one request does not rely on the execution of the other ones. Let's now switch from PowerServer apps to REST API. In REST API projects, where you build your own API.NET controllers and service, it is also a common use case to connect to different databases. So in other words, the client may want to specify the cache name which the result should be addressed to, and the API uses cache name in a data context factory. So although Snap Develop doesn't offer code generation of this type, you can achieve the expected functioning schema with little code. The scenario is the same discussed earlier in the slide PowerServer dynamic connections. So the client sends cache name to the server API as an argument in the header. So actually, you can send in the query string, but I'd rather avoid exposing this information. So just set it to the header, to the custom header cache name, for example. On the server side, a class that provides a data context factory service will retrieve this parameter from the request HTTP context and pass to the service class a data context of type specified, among, of course, those available in the API app settings configuration file, say cache A that connects the Power Builder demo, cache B that connects another SAP database, cache C that connects Microsoft SQL Server AdventureWorks, and so on and so forth. In details, this is the code example. So box on the top, the Power Builder code as easy as sending a GET request, so a retrieve operation, with the custom header cache name, which is set. And box at the bottom needs a bit of explanation. You see at the beginning how the data context is set via dependency injection. It's not used in the typical with a typical add data context method, which is part of the Snap Objects data package, to make it easier to inject data context class for us PB developers, but with the classic way to inject another class in C#, the add scoped function that it is used in Snap Develop projects to inject any server class. The data context factory here accesses the HTTP config, the HTTP context object in its constructor, and which is then used below to extract the cache name, read the corresponding database connection string from the configuration file, and create a new data context instance for cache name. Okay, demo time. Let me switch to Power Builder and snap develop. I'd like to show you one of the most important new features, in my opinion, of PowerServer 2022. So let's start Power Builder, and this new feature is the long connection property of the transaction object. When it is set to 1, it enables the installable cloud app to persistently use the same database connection for a particular client. Of course, main advantage is to have the ICA featuring the same long-running connection as in the Power Builder native client-server app, although we have discussed performance pros and cons during the slideshow. So I will now run the sales demo application, first of all in client-server, then in PowerServer mode, with a few changes needed to demo the long connection feature in a single Power Builder application, which otherwise would be difficult since I don't have enough client sessions to actually trick the database pool to use different connections for different requests in the same client. So that's the application in client server mode. The sales demo app now asks for a login and password that are searched in the person data table. It retrieves user information and stores them into a temporary table. And then this user info is shown in this user window with ID, name, and family name, which are all read back from the temporary table. So quite straightforward in client server, since any temp data are accessible, in fact, within the same unique database connection. But in PowerServer or in a three-tier architecture based on connection pooling, this code will fail if a given client writes into the temp table in one connection and reads that table with another connection from the pool. So let's have a look at the code. The user info are startup, so my W login, in a temp table. So if I check the script, I will have this save user log info. And this creates a temporary table, user info, and then this procedure stores current logged user ID, which will be retrieved at a later stage. The user info are then shown in this window. Let's see the open event. Here, first step is to simulate another user by executing a procedure at the same time. Otherwise, I would need to start another sales demo instance to use a second connection, because with only one client, the same previous connection will be most likely reused in the next database operation. So declare a new transaction object that is a second database connection, and call later some function that accesses the database. This OF simulate concurrent that declares, executes, and closes the procedure. Then, when it is time to retrieve the user info with a stored procedure in OF get user info, which is the counterpart of the one we have seen at the sales demo startup, we have a database operation that fails because previous connection has been assigned to second transaction and retrieving the user info will in fact fail. So let's run this app now in PowerServer mode. I'll take the project that I deployed already and I will run in PowerServer mode. So this will start the backend. In a moment. There it is. Now the front end of the ICA is starting as well. I can log in with this email and password and let me check the user info. Okay, the user info table, the temporary user info table was not found, and this is what I expect since at this moment I'm using a database connection that is different from the one used to store the initial user info. Now, time to set the long connection to one, and that is when the connection is established. So I'm using the Power Builder demo database. I will comment out this line, which you see contain long connection set to one. Let me deploy it again. Okay, build is finished. Let me close console from previous session and start the PowerServer project again. A new backend API will pop up shortly after the ICA. Log in, store the user info in the temp table and trying to read it back. And now I see the information. Of course, in a multi-user environment, it will be much easier. I'd say natural. So to hit the moment when the pool doesn't return same connection to a given client, and operations like relying on a temporary table, context variable, or state info stored in a previous time will eventually fail. Okay. Let's see now how to build an API project that can use the database cache specified by the client. So first of all, the PB code. And without loss of generality, for this example, I will use the two demo database installed with Power Builder 2022. The SQL Anywhere PB demo DB 2022 and the equivalent in Unicode form. We will retrieve the list of departments from human resources. In both cases, there are 22 rows, and to have indeed a feedback that we will be connecting two different databases, in the Unicode version, I have changed a bit the content of this table so that the first row, instead of being engineering, is called Engineering Elevate 2022, as well as the group name. In the test window that I will run, there is a department data window, a drop-down to select between first or second cache, and the retrieve code, which, as you can see, gets the cache name from the drop-down data window and uses the REST client object to send the HTTP GET request. The database to connect is set in the custom header cache name, and the REST client just submits the request to the API URL and fill the data window. So pretty simple on the client side. Let's switch to Snap Develop. But first of all, we run the API and the Power Builder client, and then we see also and analyze the C# server-side code. So this is the backend code, which now I will just run. Okay. Start also the client. So here I have the two cache names corresponding to the ppdemo p2022 standard version or Unicode version for cache P. Select the first one, retrieve. There is some activity here in the back, and the 22 rows are displayed. So not Elevate 2022, which instead belongs to the second database. Retrieve again. You see, still the 2022 rows, but with the first row changed, meaning I have switched to the second database. So client decides what database to connect to. Now let's discuss then the API, starting from the startup class. It's this. Okay. So to register dependencies in ASP.NET Core, you find the configure service method in the startup class and add the interfaces with corresponding concrete classes. And they are the data context factory that we will discuss soon, for which we use the add scoped method to register the service with a scoped lifetime, the lifetime of a single request. And then this IHTTP context accessor interface, which is an interface for NetCore for accessing HTTP context property. So following Microsoft documentation, you should register HTTP context accessor interface and concrete class as a singleton with try add singleton, which will register the service only if it has already been registered. So at this point, the dependency injection container supplies the IHTTP context accessor to any class that declares it as a dependency in its constructor, which for us is in fact data context factory class. So here the constructor, and in fact the dependency context, the dependency injection provides this class access to the HTTP context accessor, and in particular to the HTTP context object that encapsulates all information about an individual HTTP request and response. We can use an HTTP context instance because it is initialized when the HTTP request sent by the Power Builder client is received on this site. Then the data context factory has a method, this create data context SQL, that creates and returns the data context. So it reads the cache name header from the HTTP request. It reads the cache name connection string from the cache configuration file, that is app settings JSON, cache A and cache B. and it creates a new instance of SQL Anywhere data context, meaning it picks up a connection from the selected pool so that this is the data context that is registered with the scoped lifetime to serve the current Power Builder client request. And if you want to make the code even more general and serve any kind of database provider, SQL Anywhere, Oracle, SQL Server, etc., you can pass a second HTTP header and have the create data context method verifying this second header and creating instance of course, ODBC SQL Anywhere data context option, Microsoft SQL Server data context provider, Oracle context, etc., etc. Appreciated your attention. I will be happy to answer your questions in the next 5 to 10 minutes, and keep in touch with Appian. Community portal is the place to be, where you can find discussions, technical articles, video and free online tutorials, of course also follow up on social networks. And thank you very much again, and enjoy this beautiful conference.